Force fields are a staple of science fiction. They're in almost every story, yet they are soon to be impossible. Today, we'll challenge that assumption. When I was getting ready to do this episode, I started looking around for all the discussions I could find, examining force fields in a more scientific context. But there weren't many left to be considered after weeding out a ton that were just pseudoscience clickbait and hype. They tend to be great examples of Betteridge's law of headlines, which states that any news article headline ending with a question mark poses a question to which the answer is no. Alternatively, when I reviewed classic science fiction, I couldn't find many stories and settings that didn't have some sort of force field in them. They are rather ubiquitous for something that hasn't got much basis in known science. Part of that might come from their origin. They were popularized very early in science fiction, and once a piece of tech shows up in a sci-fi classic, it's safe territory for other writers to use. Part of it, though, I guess, is just the sheer power of weaponry at the end of World War II. With atomic bombs in play, you need something stronger than armor to resist them, because nukes beat matter every time. And of course they were just mind-blowingly cool when portrayed in movies like Forbidden Planet. And that's worth remembering too. Force fields and energy beams are a very easy special effect to do in pre-computer times that looks awesome, and damage to your shield doesn't require smashing up the scenery or expensive spaceship models. Now regarding the topic of natural force fields, they are real enough, which sometimes causes some confusion. We have 4 fundamental forces that control the interaction of matter in this: gravity, electromagnetism, and the strong and weak nuclear forces. These do have force fields, and if you can manipulate those, you can affect stuff trying to pass through them. Indeed, NASA and others have been looking at how to use magnetic fields to protect spaceships from radiation for a long time, and have made a lot of progress at using these fields to keep out harmful particles. This is our first big problem with force fields. You usually want stuff like air and light to move through them, so you can see what's going on and keep breathing. But if you've got a force field that lets light through, it would seem like it ought to let a laser through too. Not a very practical shield if you can't see the people shooting at you, but also not very useful if they can zap you right through it. In the classic sci-fi series Dune by Frank Herbert, we're introduced to personal force fields. He gets around the light issue by the laser guns having a weird interaction with them that sets off a nuclear explosion killing both people, so no one uses the one on the other. He also has the shield designed so that only slow-moving objects can pass through. Thus, air gets through but bullets and fast knives do not. In the book, the idea that the slow knife penetrates the shield serves as a reminder to be observant of where you are in time and space. It's a fairly deep and philosophical book. Plus, he presumably wanted to capture and highlight the feudal aristocracy feel of the series with knife and sword fights. So how it works doesn't actually matter, but this is common in general for personal shields in fiction. Except that in this we have a problem. We think of air moving rather slowly. Even a strong gust of wind moves a lot slower than a baseball, let alone a bullet. But in fact, air particles themselves individually move quite quickly. Those particles are usually zipping around a bit faster than the speed of sound, meaning they aren't getting through unless many bullets would. And while we generally make bullets that travel between Mach 2 and Mach 3, you can use a heavier bullet traveling a bit slower to do the same damage. And all of our favorite melee weapons like clubs, swords, and axes are subsonic too. If we try to argue that only large chunks of matter, not small particles, actually count toward that barrier, then we have to worry about particle beams, or maybe just someone shooting us with a water gun, one that vaporizes the water into steam on the way out, which is perhaps not practical as a long-range weapon, but very painful and effective at close quarters. The same holds for a flamethrower as well. Now, those don't really matter for the purposes of the story. Dune, after all, has a ton of plot holes when you think about the science, but it is still one of the best science fiction series ever written. Still, it is those kinds of issues which we need to think about when contemplating force fields. We might be putting the cart in front of the horse here though. Before we discuss what you can use the technology for, it is worth pondering whether we can actually achieve the technology one day. However, to do so, we need to first understand what this technology is, in terms of its properties, to discuss it. What force is the field producing and controlling? What gets through, and what does not? The perfect classic force field stops everything, and I think are so popular in TV and films because beam weapons and force fields are very easy and safe special effects compared to bullets and explosions, point defense systems, and so on. As I said earlier, it's very expensive to smash holes in your spaceship when it is a real model someone assembled from plastic and glue. These days we tend to see more of each. Indeed, we often see rock, paper, scissors systems in video games. For attack they have projectiles, beam weapons, and missiles. For defense, armor, force fields, and point defense, with some working better against others. This is probably a better approach to consider though, and I don't mean because it is more interesting than just beams and shields, but because we can more easily contemplate a shield that works against something specific. As an example of this, we have the plasma window, something we discussed using in the mass driver episode to keep air out of the device, which is essentially a big long tube you want to keep as a vacuum. It is actually pretty simple in concept, though harder to get working. Plasma is one of the 4 basic states of matter along with liquids, gases, and solids. While plasma itself is electrically neutral, just like most matter, its constituent material is all separated and ionized. That means it all responds strongly to magnetic fields, so we can keep it bouncing around inside a magnetic field that we control. If air tries to get in there, it gets pushed away, for the same reason cold air has problems getting into a warm room, if none of the hot air inside can escape. Plasma is very hot, so if you keep a pocket of it at normal pressure or higher, other gases won't enter, so it acts like a force field against them. But large fast objects can move through easily enough, though you wouldn't want to stick your arm in a plasma window unless you needed a quick tan or really wanted third-degree burns. Something like this isn't a bad personal shield since punching folks through one isn't a great idea, but it won't stop bullets and it won't stop lasers. It might stop particle beams. This type of shield, improved enough that you could carry one around on your belt that forms a protective cocoon around your body, would let them walk around on an airless planet without a spacesuit, though sunscreen would probably be a good idea. It would also let you have airlocks on spaceships without needing to pump the air out or lose it. Flick on the plasma window, open the airlock door, jump through. We have the technology for this now. It's rather basic and energy consumptive, but it works. Could you ramp this up? Use it to contain so dense a plasma that a coherent laser couldn't get through and bullets and such would be incinerated? Possibly. Maybe a series of toroidal rings around the person or object like a stack of donuts full of dense plasma. Such a thing ought to be a monstrous energy hog, but we can't rule it out, and trying to get a field that can do just that is the basic concept behind a tokamak fusion reactor. So a civilization with compact fusion reactors that worked this way might be able to do it. Problem is, the thing glows rather brightly. It is a superheated gas, and with a color based on that gas. We use it for making light after all. Those really nice plasma TVs aren't called that as a marketing gimmick. They use plasma to make the various colors. If you are running one at high enough energy and density to be vaporizing bullets or scattering laser beams, you ought to be glowing like a lighthouse, which is not what you want if you're the guy standing in the middle of it, since it would probably vaporize you too. You might stick it on a big ship with reflective sides, which would also help against a laser, but you'd be a pretty big target. Of course, to be fair, as we said in the space warfare episode, there's no stealth in space anyway, so it's not like it matters if they can see your shields. It's also hard to see outside such a thing. We get that issue with opaque shield or cloaking fields in sci-fi a lot. The two obvious workarounds would be a thin wire through the shield with a camera on it, or flicking off segments very quickly to get a look, and doing so in a random fashion so that the enemy can't determine the frequency and pattern you're doing that at to sneak something through. That last works fine, if you can turn the shield off in places and turn it back on again real quick, which you can't really do with a plasma window, for instance, since you need to have a reservoir of gas to be the plasma, and inject it in there and heat it up. Shut the field off and it takes a little time to disperse for you to see through. The wire through the shield to a camera is a little trickier. Not because those cameras will get blown up a lot. Cameras are small, wires are small, treat them as expendable and send more. Rather because that wire needs to be insulated against the shield somehow, and if you can insulate the wire against the shield, you can insulate a projectile slamming through the shield too, which is fine if you want to send bullets out at whoever is attacking you, so you don't have to flicker your shield, but presumably, they can insulate their bullets coming at you too. Classic problem, of course. We get a technology that makes a good weapon or defense, and then someone spends their energy trying to use that same technology to defeat that tech, and you often can. Steel armor is better than bronze or leather armor, but if you can make steel armor, you can make steel weapons, and a knife or arrowhead uses a lot less steel than a suit of full plate. Regardless, the plasma shield concept has some real possibilities, even in the near future, but doesn't seem a great candidate for a classic sci-fi force field. It is an option, but can we do better? Real objects feel solid because of the electromagnetic force between particles and the Pauli exclusion principle that keeps them from occupying the same place. We saw in our discussion of active support in the Upward Bound series that while we can use this to provide passive support to an object, just as a cup sits on a table or a coat hangs from a hook, we can project particles at something to keep it in place. It can work as well, or better in some cases, as sticking supports under something. The idea of levitating matter kilometers up in the air can seem a bit counterintuitive, but it works, and you can see a real-life demonstration of this over at Cody's lab. He kept a pie tin levitating quite high on a simple stream of water. If we can do this constantly to replace metal supports, we can also do this in a very short-term and pinpoint fashion. Something attempts to enter the field, and instead of an impenetrable wall of force, it simply pushes back against the object in a carefully calculated way, possibly using a reservoir of pushing material, possibly a closed loop, or possibly using material already present, like the air. A lot of folks will remember articles a couple years back about DARPA or Boeing having a four-wheel force field, and it's kind of true in a pretty literal way. What kills a lot of soldiers isn't bullets. Armor is actually quite good at stopping those, but traditionally in modern warfare it's explosions that kill most people. When an explosive goes off, you have a big shockwave and shrapnel. What this sort of force field is doing is trying to attenuate that shockwave force. And modern electronics and computers can move very quickly, something that we need to consider when looking at these concepts. An explosion goes off near a vehicle. It is moving very fast, but not at light speed, nothing like it. So that explosion can be detected before it hits, and the vehicle emits a powerful burst to turn the air between the vehicle and the approaching shockwave into a plasma-like medium, disrupting the shockwave. Conceptually, this is a lot like reactive armor or an airbag, and we can consider airbags as a type of shield too. We don't live in the 1940s when sci-fi was all about rockets and ray guns, and computers were huge things that took up buildings. We live in an era where computers are tiny and fast, one where we can consider stuff like point defense, not just shooting missiles down, but maybe even tiny bullets. So instead of the classic force field, maybe you are walking around with a ton of tiny lasers or guns on you, each automatically controlled. Instead of needing a shield that lets particles of air through, you've got a smart system that only turns your protection on the instant it needs it, and better yet, the place where it needs it. Someone goes to stab you, and the shield only pops up in the exact place to intercept it, or at the right spot and angle to deflect it away. If we don't have that, maybe we can mimic that with a bunch of small point defense. It detects a bullet, it shoots the bullet with a tiny one to deflect and fragment it. Now it normally couldn't intercept a laser, but it might be able to detect that one is aiming at you, and shoot something in the way to intercept and defuse it. We don't have many laser weapons yet. We use them with a lot of weapons, but they're not a great anti-personnel weapon by themselves unless you have either a very compact and high-power generator or some really awesome batteries. Lasers, even modern ones, are not too efficient, and batteries don't tend to store a lot of power nor discharge it too quickly, so chemical-based propellants, firearms, are still a lot better. If that changes, we'll start seeing laser guns. Realistically, you kind of need stuff like that for a force field too though, so if you've got personal force fields, you probably have man-portable laser and particle weapons. We can deflect a particle stream magnetically, but a laser is harder. What stops a laser? Well, a laser is composed of photons, but they are the carrier for the electromagnetic force, and while they transmit it, they are not affected by it. No magnetic shield is going to stop a laser. Gravity can. It bends light and can red or blue shift it. So if you had some way to generate gravity, or better yet, anti-gravity, you could have a field of that, which could redshift a laser beam down so it was too weak to hurt you. Better yet, instead of an omnidirectional field, maybe a beam or focused blast of it to just redshift the area the beam is entering. But if you do have gravity and anti-gravity, then you also probably have a new kind of weapon to contend with as well. Since we don't have any way to generate gravity besides raw mass, and anti-gravity is one of those topics that occupies the hazy area of physics, while anti-gravity would be a massive game-changer technology, we'll save discussing that for another time. In the absence of that, we can use reflective armor, or even reactive armor that explodes when punched. That is handy for stopping projectiles, an explosion that pushes back against the incoming projectile essentially, but those also put a lot of vaporized matter in the way that diffuses an incoming laser beam too. Alternatively, we have the option of shooting that out away from us, in between the beam and the target. A tiny mirror that gets in the way, or a pocket of gas to disrupt and absorb the beam. Notice though that we keep talking about focused, smart defense, not some big dumb bubble around you. Partially because that seems to be what physics allows us, but mostly because it's smarter. Instead of a big bubble on all the time, burning power, something that is pinpointed in time and space. That is rule number 1 of warfare: smart beats dumb every time. It doesn't replace armor, and neither should a force field, since nothing quite replaces the value of lots of dumb matter in the way to absorb damage. But there's always a cost to that. Walking around in body armor is exhausting, even the modern lightweight stuff that's flexible. If you ever need to lose weight fast, grab yourself a nice Kevlar vest and ballistic plate, and go jog around for a few hours. Builds muscle and burns fat, though a treadmill is better for the back. But whether we're talking about body armor or vehicle armor or armor on spaceships, it slows you down and makes you less agile. This is a big no-no under rule number 1 of warfare, which is to avoid getting hit. So some system, like a suit of liquid armor that could detect an approaching impact and flood that spot with the fluid, or a personal point defense system that could shoot stuff out to block a hit like a classic shield, would help. And by classic shield, I mean old school, a thing that gets in between you and the other thing trying to kill you, not a force field. So in some ways, we're seeing that even if a force field is possible, it maybe isn't what we ideally want anyway, not unless it only expends energy when it gets hit. Ultimately though, to get a real force field, we want technology that can play with gravity or inertia in a very significant and controllable way. But let's say we have something like that. What is it good for besides keeping you from getting killed? An application that admittedly is quite valuable even if you can't use it for anything else. We have the obvious one. Instead of using armor, you use shields. But you can take that a step further and replace your hull entirely with force fields. I mean, the point of a spaceship is to keep the air in and keep the radiation out, so a bunch of force fields do the same thing. Unless we're sticking to the notion of some magic single bubble, you'd presumably have lots of individual ones, and backups that could kick in if a chunk of the pseudo-hull fails. I think you'd still want some actual hull as an extra backup, and to keep folks from going insane at the thought of them failing, but you could keep it to a minimum thickness. This lets you do much better with active support structures too. We discussed those in the Upward Bound series, and this is basically the same concept. Instead of needing a big foundation and pylons to hoard a building miles up in the air, it's just resting on a force field instead. Fundamentally, a lot of our limitations on doing things don't come from basic physics, but rather from all the engineering constraints placed on us by the fundamental limits on material strength from chemical and atomic bonds, or getting rid of all the heat built up doing stuff. That's an issue for stuff like star lifting, for instance, the process of magnetically scooping matter off a star that we've discussed before. You need to be close to a star to do that, and stars tend to be rather hot. We can use magnetic fields to deflect away charged particles like plasma hitting stuff near a star, and make the exposed surface very reflective so light doesn't heat it up. But that's very tricky to get just right, so you can put stuff near a star. A force field alters that equation a bit, though it depends on how it works. Heat buildup tends to be a big handwave with sci-fi force fields. If you've got some shield that can shrug off atomic blasts hitting your spaceship, and energy beams that could roast cities, where exactly is all that energy and heat going? Is it bouncing away? Ought to be giving your ship a big shove in the process, even if you can bounce it all. Or are you absorbing it? If so, where to? Your ship? The energy released in an atomic blast, even if you can distribute that all evenly so it's just heat added to your ship, would probably be enough to roast every person on that ship. So if we are assuming it can deflect nuclear blasts and their energy, you've got something that can let you casually fly into a star, or at least hover right over one. If it's good enough to let you go hang out in stars, that's a pretty nice place to hide stuff, like entire civilizations, which is our topic for next week. Force fields are a lot like replicators, the ones from Star Trek that make stuff, not the ones from Stargate which, actually, also make stuff but mostly more of themselves and in a hostile, grey goo fashion, not a tea or grey fashion. But force fields are like replicators. The more you think about it, the more you come up with stuff it can do that's so awesome it kind of spoils the show when you think about it. Replicators are a lot like a magic lamp with a genie. Your first wish is for more wishes, and the first thing you replicate is another replicator and the power plant that runs it, which is more or less how the Stargate replicators, Grey Goo, and von Neumann machines work. Then you tell half of them to keep replicating, and the other half to build stuff, like spaceships with force fields. You can use a force field to make a window. We often consider walls with TV screens that are so high resolution they can just switch from showing you the news to the outdoors just like you were looking through a window. But you can probably tune a force field to act like a TV too. I mean, if it can block light, it can presumably do that selectively. Or a set of speakers. After all, sound is just vibrating waves. So maybe your personal force field isn't protecting you, it's cloaking you and making a decoy that looks and sounds like you a few feet away. Gives you the option for very realistic holograms too, things you can see and hear and touch, and also lets you remotely control stuff a lot more intuitively than piloting a robot drone. Maybe you don't use steel plows on farms anymore, just run some force fields through them to churn the earth instead. Maybe that's how you plow snow off the roads in the winter. Maybe you pop them up over roads to bounce the snow away in the first place. You do not carry an umbrella, one just pops up over your head and shoulders, or over the boulevard. All the fun of walking in the rain without wet clothes. No soft mattress or gel padding, your bed is a force field that tunes to the right comfort and support. The soles in your shoes carefully absorb the impact of your steps better than gel or rubber. You don't break your ankle jogging over a groundhog hole or your car axle driving over a pothole, because your shoes or car see it and drop a force field right there. You don't slip on the ice because it makes that spot have friction and tread. Your handy personal force field keeps out bad odors from your personal air from folks who went jogging but skipped on a shower. You maybe don't need sunscreen either because it keeps ultraviolet light off you, not the rest. Good way to heat and cool your house too, or your planet, if you can selectively tune what wavelengths of light can pass through or reflect, or what speed of particles can get through and what can't. Come to think of it, if you can selectively let only certain speeds of particles through while bouncing others back, you might be able to tell the laws of thermodynamics to buzz off and separate warm fluids into a hot and cold side. Those aren't as awesome as a personal force field that bounces off bullets or lets you walk around on an airless planet, but at a day-to-day level they are a lot more handy, especially that last one, which is basically Maxwell's demon and a perpetual motion machine. We do not have a roadmap to force field technology, but we've seen some gimmicks that let us do about the same thing, and maybe that's another example. It would be neat to have an invisible bridge between two tall buildings instead of a solid structure, but perhaps instead of a force field bridge you can walk across, something that just pushes against your feet in midair, targeting every step to provide pushback as you walk. Micro-size something like this enough, and with enough computer power, and you could have a holodeck like in Star Trek, but where it's only making solid stuff when you're touching, applying just enough force by shooting stuff there at just the right moments and locations, possibly so fine-tuned you could feel textures and heat. We have no way of knowing what cool new physics might emerge in the future that maybe allows us the classic force field, but we've seen today some of the options that allow us close equivalents or alternatives, as well as some of the cooler uses this technology might permit that we tend to skip over when thinking about spaceships and ray guns. Personally, I wouldn't expect that we'd ever get the classic force field, but it's not something we can rule out entirely yet, and those close equivalents and alternatives at least are decently plausible. Next week we will be returning to the Alien Civilization series for a look at hidden civilizations in Hidden Aliens. For alerts when that and other episodes come out, make sure to subscribe to the channel, and if you enjoyed this episode, hit the like button and share it with others. Until next time, thanks for watching and have a great week.